Have you ever wondered how random forest works in ensemble learning? Well, today we're going to delve into the world of machine learning, where we'll unravel the mystery behind this fascinating concept. Imagine a single tree. It's strong, it's tall, and it can withstand a lot. But put a bunch of trees together and you've got a forest. A force to be reckoned with. That's the basic idea behind random forest in ensemble learning. It's about creating a forest of decision trees to come up with the most accurate predictions. Now, what's a decision tree, you ask? Picture a flow chart where each node represents a feature or attribute, each link represents a decision, and each leaf represents an outcome. A single decision tree is a powerful tool, but it has its limitations. It can overfit, which means it can get too caught up in the training data and perform poorly on new, unseen data. That's where random forest steps in. It's a kind of ensemble learning method that operates by constructing a multitude of decision trees at training time and outputting the class that is the mode of the classes of the individual trees. In simpler terms, it's like conducting a survey. Each tree in the forest gets a vote, and the outcome with the most votes wins. One of the beautiful things about random forest is that it helps to correct the habit of overfitting to the training set that decision trees have. It does this by introducing randomness into the model when creating the trees and making a prediction. It's like adding a pinch of salt to a recipe. It doesn't change the main ingredients, but it enhances the overall flavor. So, how does this randomness work? Well, when training, each tree in the random forest gets a random subset of the training data. This process is known as bootstrapping. Furthermore, when splitting a node, the split that is picked is no longer the best split among all features. Instead, the split that is picked is the best split among a random subset of the features. This randomness results in a wide diversity that generally results in a better model. Therefore, in random forest, only a random subset of the features is taken into consideration by the algorithm for splitting a node. You can even control the number of features that are considered for splitting at each node. So, in essence, random forest is a powerful and versatile machine learning algorithm capable of performing both regression and classification tasks. It also undertakes dimensional reduction methods, treats missing values, outlier values, and other essential steps of data exploration, and does a decent job. To summarize, random forest in ensemble learning is like a team of decision trees working together. Each tree is trained on a random subset of the data and gets to cast a vote on the outcome. This forest of decision trees often achieves better accuracy and performance than a single decision tree, making random forest an essential tool in every machine learning enthusiast's toolkit. So the next time you're faced with a complex machine learning problem, remember the power of the forest. After all, as they say, there's strength in numbers.